Welcome, ladies and gentlemen, to FOB TV, the future of business. I'm your host, Kevin Benedict. I'm a futurist and lecturer here at TCS, and I want to welcome all of you to the program today. So we're going to be exploring the forces shaping tomorrow's businesses, technologies, and human intelligence. That's what we do here. And today we're pulling back the curtains to learn what it really takes to support the future of automobile manufacturing from a data perspective. I have often written about the concept of OILS, Optimized Information Logistics Systems. And I use that acronym to describe how you want the information to move through a system to optimize its utility and value. So that's the word I use, but I'm sure that's the wrong word because everybody has their own. But to help us make sense of this evolving landscape, I'm joined today by expert Matt McLarty. Matt, thanks for joining us.
Thanks, Kevin. Great to be here.
So Matt is the Chief Technology Officer for Boomi, which is having a boom time right now. Look it up. He helps organizations around the world thrive in the digital age. He is deeply involved in the worldwide API community and has led global technical teams at Salesforce, IBM, and CA Technologies. He has also co-authored books for O'Reilly and co-authored the book Unbundling the Enterprise from IT Revolution. He is also the co-host of his own podcast, The API Experience. So thanks again, Matt, for joining us today. Where are you calling in from?
Well, with all these Beatles posters in the background, you might think Liverpool, but I'm actually calling from Vancouver, BC, Canada.
Oh, man, one of the most beautiful cities I've ever had the privilege of spending time in. Mountains right behind you, the water, the food. You guys have every ethnic food in the world there.
It is a great food town for sure, and its natural beauty. I have to tell you though, today it is a torrential downpour. So that is December in Vancouver, but we can always go to the mountains and ski.
Well, I'm in the desert, high desert here in Boise, Idaho, and we're getting rain like crazy today too. So yeah, it's covering the West Coast, it looks like here. So now you have your own podcast. Mm-hmm. How long have you been doing it? And how is the experience? What do you feel when you do those podcasts?
I love it. I have to say, I don't have stage fright here, but I got to adjust to the video thing. We do audio only. Yeah. Which makes it, I do that because I do the post-production too. So, but It's great. Actually, my co-host and I, Mike Amundsen, we've had podcasts. This is the second one. We started doing podcasting like 2 months before lockdown in 2020, which was timely.
That's it.
We've had a great experience over the years. It's API themed, but we cover a lot of ground. A big highlight was one of our most recent guests was Tim O'Reilly, who's the founder of O'Reilly Media, and that was phenomenal because the topic is about APIs, which we'll talk about quite a bit today. But I would say he's like the person of all people in the world. He's the one who really pushed the API agenda with his whole Web 2.0 movement back in the 2000s.
Well, that's awesome. When you get a guest like that can just give you these deep, not only current, but historical insights. That's just phenomenal.
He was amazing. Yeah, he's all into, he had a really interesting perspective on the AI boom going on too. So,
I love it. So you've co-authored the book Unbundling the Enterprise, and it explores patterns of success in digital business with case studies from companies like Cox Automotive, Google, Best Buy, Amazon, and others. What are the main lessons that any organization can apply, and how does it relate to the current AI revolution?
Yeah. So my career has been very much working on connectivity, integration problems. I would say about 15 years ago, when the whole API economy exploded, right? We had things like, the second generation of web apps like Uber and Airbnb and all these other things that were really built in the back of APIs, very much focused on API-based connectivity. So my co-author, Stephen Fishman, and I, Stephen's a colleague of mine here at Boomi, we kind of were like, in all industries, we've seen this explosion in this. We had the digital transformation movement, which was like the top of the headline until AI wiped everything off the map.
Yeah,
But
I was
working
there.
exactly, working with companies across all industries, we saw that there was just this common denominator that like the companies who really understood how to leverage APIs to their advantage seemed to be the ones that were most successful in the digital economy. But we also had a hunch that it was more correlation as opposed to causation. So if APIs are part of the story, but they're not the whole story. So we wanted to go deep on what is it about this, leveraging APIs that seem to position all these companies for great success in the digital space. And I think we did Cox Automotive, which has sort of a unique place in the automotive industry. But it was really kind of across the board, just these patterns of optionality was the big concept that was common across all of them. And if I could characterize one thing that I think is ultimately the thesis of the book, because the full title is Unbundling the Enterprise, APIs, Optionality, and the Science of Happy Accidents. What we found with these companies is that a lot of the things that led to their ultimate success weren't done intentionally. It's like they did some stuff and then like a customer came in or customers came in and said, "Hey, we noticed you did this. What can you help us do this other thing?" Like Google Maps. Like Google Maps was just an experimental app that was thrown out there, and then all of a sudden developers in the ecosystem just started creating apps that were hacking the API behind Google Maps, and they're like, "Hey, we want to use the API. Can we pay for it? Can we give you our money for the
Yes.
service?" So, and what we found is that the reason we call it the science of happy accidents is because these things happened unintentionally, but is there a way to actually deliberately create these sort of happy serendipitous occurrences? And we found like basically if you take yourself away from this mindset of I'm going to have a 5-year strategy and we have to do all these steps and ultimately we're going to try and get to this one goal. That's a bad path. Like that's a path where you're actually closing doors as opposed to opening
Mhm.
doors. And the best way to do things is actually to create an environment where you have all sorts of options. So you might build a solution that is for one purpose, but if you build that solution in a way so that you could break it down into 20 different piece parts, those 20 parts may have applicability across these other areas, other ideas you haven't even thought of. And we use this analogy of like a treasure hunt and how pirates looking for treasure might spend years building a boat, getting a crew, and then going to an island and digging a hole and there's nothing in it, right? Whereas what you really want to do is dig up the whole island or dig up the whole archipelago and find all the treasure where you don't even know where it is. So APIs, the reason why APIs have anything to do with this is because that's kind of the way, if you build your digital systems in a way that everything is connectable and can be applied in different contexts that you haven't thought of, which is what happens when you build sort of an API-based architecture, then you're setting yourself up with all this optionality in your environment and you can build from there. So that's the net of it. And I think it has universal applicability across all businesses. I mean, that's kind of the way Amazon was built. I mentioned Tim O'Reilly. A lot of
Yeah.
what he did in the early 2000s was talking to Jeff Bezos and convincing him, hey, this is the way of the future to do these APIs. And Amazon rolled out that way so they went from being like the online book retailer to being the everything store plus cloud
Yeah.
computing giant, right? So
And
anyway, that's kind of the way it's done.
and if everything is going to be ultimately an ecosystem, that means everybody needs to connect to everybody just about. So
Exactly.
I could really see it.
Yeah,
Really
and
see
I think like it really is a changing the mental model. Like if you think about if you come up with a very precise plan, you might think that this is the way to drive focus and success, but it's also the way that you close so many doors. So I think it's that mind shift of just thinking about how opening up all the doors yeah, in an ecosystem environment. And optionality doesn't work everywhere. Like if you're in a very known place and that's already the patterns of optimization are known, then you want to just stick with what you already know. But when you're in a volatile, high change environment, that's where you need optionality the most. And that's definitely where we are in the digital world today.
Oh, so I must ask, this is kind of an aside, but on your website, it talks about EDI, electronic data interchange.
Yeah.
I kind of started out early in my career actually teaching classes on EDI and going all around the world doing supply chain trading partner on ramping with EDI and all kinds of stuff. EDI has been around for half a century or something.
EDI is the origin of Boomi way back. But the EDI, you know what I love about EDI is it's the perfect example of, if you look at it from a technologist standpoint, you'd say, hey, this thing is old, it can be potentially brittle. Like, why haven't we replaced this yet? Well, it's a known thing. Like this is a known, it's a very, what is it? I think, is it crocodiles that have been like evolved at some point millions of years ago and they just never changed because they're the perfect species? Like maybe EDI is the crocodile of the digital world, right? It serves the purpose.
I've heard it called crocodile, but I've never heard it called the perfect solution.
Okay, fair enough. So I'm a big believer in like embrace the chaos. I think in the technology world, we have this silver bullet mentality of like, oh, I'm just going to come up with this one thing. It's going to simplify everything, and then all the old stuff will go away. That's just not how it works. Like complexity is not something you get rid of in the technology world. Complexity is part of the beauty. Like think of the beauty of life. Everything that's beautiful is complex, right? So we look at these legacy environments and we might think, oh my God, it's a spaghetti mess. Maybe it's actually a thing of beauty, right? But we never really replace anything in technology. I like to say, we like to use terms like ecosystem and landscape to describe technology, but it's not really biodegradable. It doesn't break down. It just kind of sits there. It's more of a landfill. So we've got all these layers of technology. The thing is, EDI works for what it's doing, and it's also interoperable with other things. Like we actually have solutions that provide like AI-based reasoning, agentic reasoning over the top of EDI landscapes to just simplify and automate parts of the EDI lifecycle. But it doesn't mean you have to replace EDI, and it's particularly hard to get rid of something that is entrenched in multi-parties, right? Because if you think about moving to another protocol, you'd have to switch everybody at once in a way. So, but it's there, it's doing the job, and there's still, maybe there will be some phenomenal alternative or something mandated, but it's there. But
do you know how many alternatives there's been, Matt?
Oh yeah.
All the XML variations of standards that came out that were going to replace within months EDI.
Oh,
they never did.
From a technology standpoint, it's just logical. Like, why wouldn't you go that way? It was the same thing. I started my career in banking. The same thing in banking with ISO 8583 payment transactions, or these compressed binary messages that were like, oh, we've got to get rid of those. We're going to go to the XML thing or the SOAP thing or the JSON thing, right? It's just, they're there.
And Swift is still operating.
Oh, for sure.
So, I think this is actually a good tie-in to where we want to go with our discussion on data and the automotive industry and all this, because the automotive industry, man, it's heavy with EDI.
Oh, yeah. Well,
this is one of those things where you always thought it would move fast away from EDI to something better. But maybe there's a lesson to be learned about why automotive industry doesn't seem to move as fast as consumers want it. Like we're now looking and saying, where's this autonomous vehicle we were going to have in 2017? Where is the charging infrastructure's growth plan? It was supposed to be everywhere, and it's not. So what's slowing progress down in automotive?
Well, and the thing about automotive is like there's so many layers to the whole ecosystem, right? Like you've got the driver experience, you've got the manufacturing, you've got the suppliers, you've got the infrastructure to support the experience, you've got this whole self-driving car thing. All of those reflect this reality of the complexity not going away, right? Like if we lived in a world, if we just take self-driving cars, for example, if we lived in a world where you just said, okay, like a Y2K moment, like on this day, no one's driving anymore. It's all going to be self-driving cars. It would actually be easier to make that switch. because you wouldn't have to live with the reality of commingling people driving and machines driving, right? It was all machines. They could understand each other better, but nobody can understand what people are going to do behind the wheel.
Yes.
So you got that. I mean, I think the in-car experience stuff is a real reflection of the balance between what makes sense to provide flexibility and dynamic sort of, preferential based processing, and the reality that an automobile is a large, dangerous machine potentially and can cause a lot of damage. So the balance between the safety and security and predictability with the more dynamic elements of, user experience. And then, of course, the ecosystem of suppliers and so on is so complex now compared. Like we've talked about it. I think we talk about in the book, like the sort of the 20th century business model of Ford, buying rubber plantations in South America to have a completely closed ecosystem and own things end to end as a competitive advantage at that point, to the point now where like there's this hyper connectivity and diversity of suppliers. Like there's massive complexity there. So anything in the supply chain is massively complex. So I think that what we may get frustrated as consumers or in automotive insiders and be thinking like, oh, we're not going fast enough. But it's just like playing in that space is really important. And respecting the complexity is really important, and understanding how to sort of dance with the complexity is how you win. But I think the number one problem I see, and this isn't limited to the automotive industry, is just we always want to do technology for technology's sake, I feel like. And that just causes so many problems. And this is like in spades with AI right now. Like there's all sorts of pressure. It's not just coming from the techies. Like there's downward pressures from CEOs and saying like everyone's got to do AI stuff. I need an AI plan. But AI is it's not a business outcome, right? In fact, we can see this. I mean, I feel this today when I go to do anything on the web and I get pop-up saying, hey, our AI assistant can help. I'm like, I don't need your AI assistant's help. I know what I want to do. So just getting in the mentality of solve the business problem, like that's number one. And I think that sometimes the technology, as wonderful as it is, can create noise and distract people from just focusing on the business problem. Again, going back to that EDI example, it does what it does. There's real business function there and it's doing the job.
I think for many of us who went through the whole .com era, we can see how everybody had simpler ways or better ways of doing it, yet they didn't work, economically during that period. But ultimately, they all led or provided value to the industry, just not in the time frame they wanted it to. So a lot of times it just takes more time than people want to give it, doesn't it?
Yeah, for sure. I think there's a quote that gets attributed to Bill Gates, but I did some digging on this. I think referencing in the book, it goes back a while before him about, we always overestimate what we can do in a year and underestimate what we can do in 10. Right? And I think the reason for that, I get into in the book as well, is like, it's actually the combination of all the innovations that lead to the big breakthroughs, right? Like now with what we're seeing with AI was a combination of all this web-based connectivity and algorithmic, academic research and gobs and gobs of data that we're able to pull from places. Like without all those preconditions, then we never have these big breakthroughs. But yeah, I think I think if you looked at some of the advances in all the aspects of automotive, like we are a lot farther along. And I think a lot of the, breakthroughs as well come from that shift in thinking, right? Like I think if you look at the mindset of, let's say, how a Tesla car is designed and built, it's like, as opposed to thinking of it as a car, it's like, think about an iPhone on wheels kind of a thing. It seems like the mentality of it, right? Like it's
that software defined vehicle, right?
Exactly. Yeah. And I think that's where, it's like the meeting of the minds. And again, it's why you want to be open and, be taking in all the different perspectives in an ecosystem type approach to make the big advancements, as opposed to having one research lab in the basement of the building where you expect the big idea to come out.
So you've been around, you've looked at automotive, you've just been involved in that. How have you seen it evolve, especially from a data point? What are they doing different today than they were 10 years ago?
Yeah, I think there's been some like big time advancements, obviously, in terms of vehicle telemetry and digital twin stuff, like all the areas of digital innovation have been exploited well, I would say, in the automotive industry. I think that if we break it down from a manufacturing standpoint, you just mentioned software defined, right? I think we're seeing more of this. We went through this in the networking space like 20 years ago, where we went away from more hard-coded packaged appliance type firmware based network infrastructure to being much more open and being API enabled and being able to dynamically adapt and so on. And we're seeing more of that happening in the manufacturing space as well now, where we've had more like rigid robotic firmware type manufacturing. We're always trending towards opening things up and making things more programmable. So that there's huge possibilities there. I think, again, though, going back to what I said, one of the contentions that we'll see in the automotive space is one of the contentions we're seeing now generally in the AI space, which is when you get like a groundbreaking technology like Gen AI, there's a temptation to just it's the silver bullet now. Like you can use it everywhere. And so where we are in the Gen AI space is we're kind of in the art of the possible phase. So if you go out and read the literature, it's all like, hey, we could come up with AI agents to do all the automation things that you know, every single thing. Exactly. When it comes down to doing that at scale, all of a sudden there's a whole optimization filter that needs to be applied. So if you're taking an example of like some sort of automated process today that does most of what it needs to, but if there's an exception, everything, halts and you have to get manual intervention and get things like in that case, there's a temptation to say, throw out that old thing, like just bring an agent in and it'll figure out everything that needs to happen and you just get the agent to do everything. Well, the reality is Gen AI technology is probabilistic, which makes it a little unpredictable. It's not going to do the same thing every time. And it's expensive from a monetary standpoint and from a performance standpoint. So we're right now in the AI world figuring out the balance between, where can you apply the good old deterministic, repeatable stuff, and where do you really need the brain of AI to step in? And if we follow kind of the way the human brain works, there was a great book a few years ago called Thinking Fast and Slow by Daniel Kahneman.
I've got it.
Right?
I've got it right
up
over
there,
here.
right? So remember, he's talking about system 1 and system 2 in the brain, right? System one is the autopilot, like everything you do by muscle memory, just, you don't even think about it. You just do it. System 2 is when you have to engage the thinking brain. And the brain's lazy. The brain only ever wants to use system 1, only ever goes to system 2. I think that's the pattern that we're seeing as actually being optimized in the AI world. And I think it's the same thing that will be applied in more as we get more of the like IT/OT convergence and more software defined capabilities on the shop floor, on the manufacturing areas. It'll be the same thing. Like special use, only make the system think when you absolutely need to. When you do that though, like even a little bit goes a long way. So in the example I gave, if you can take a process that works 80% of the time, but 90% of the cost happens when something goes wrong, and you can take that 90% and pull it down with some like intelligent exception handling, it may not be as sexy as like, machines running the whole company, but it's hugely valuable. And again, it goes back to the idea of like, what are the business outcomes you're looking for?
Wow. So let's talk about smart factories. If we walked into kind of an ultra modern smart factory, where might we see Boomi at work?
Well, this is I think the funny thing about AI is, and I'm biased here, so I'll declare my biases. The world that I've grown up in is all about connectivity and APIs and plugging things together. I think it's fair to say the hardcore intelligence models that are out there, it's not going to be advisable for companies to go and try and create their own AI labs that are going to outdo some of these AI centers and companies that are just so totally specialized around AI.
Mm-hmm.
The amount of data, the amount of knowledge, like it's there will be some like taking models and fine tuning them and training them your own way and things, but we're going to be relying on a lot of these big models that are out there from Anthropic and OpenAI and others. So getting value out of those new technologies becomes an integration problem, because the way you can generate business value from those models is by actually giving them context. So they know a lot of stuff. They're jacks of all trades. But if you want to apply them in your own environment, they work much better when they're dealing with precise information. Mm-hmm. So, you don't want them to have to access the part of their brain that has to do with, card games when they're trying to solve a business problem, right? Yeah. You want to keep them very focused. So precision of context is really important. Wow. That is an integration problem. Like, that is, how do you get the data into those and combine the data with those models to have the information they need to make good decisions? And that means, not necessarily giving them all the data, but actually giving them exactly the slice of data they need to make the decision at the time, which, isn't something that you're going to readily have. Oh, look, I have this data store over here that is exactly the contextual information. So it's really pulling from a number of sources, synthesizing it. So, and that's one of the things we do. The other thing that drives business value through intelligence is giving these new software components, these AI agents, the ability to take action, to actually do things. And how do you do that? Well, that's another integration problem, because if you're, the doing thing could be a robot in a factory performing a function. It could be a popping a message up to a person who needs to intervene. It could be in a more of a supply chain or e-commerce context, putting an order through or checking a customer record or so on. And to do that, to connect the brain to those functions, again, is another integration problem. So, we see that sort of helping to provide these new pipelines of context into the intelligent components, and then empowering them to take action is really what our platform provides. So in a smart factory context, like, there's a lot of operational infrastructure that you want to, if you want to connect the brain into that environment, either from an on the floor ops perspective or back office, out to the world, those are all integration problems.
I love it. So everybody talks about digital twins in the context of smart factories and everything else. I guess I should ask first, is there a connection is there an integration challenge you guys could solve that involves digital twins as well?
Yeah, again, like, I think digital twins is a pretty high level concept that we have a lot of these concepts that are very broadly defined in the industry. Like, even if I say AI agent, mm-hmm. that could mean 15 different things. Yeah. The context is everything. So, I mean, digital twins, how they're used, the sophistication level of the digital twins, the more you go up the maturity curve there, the more and more there are data challenges, I would say. And again, it comes back to precision. So, if you're just using sort of a design time digital twin concept to drive design, yeah, you need to pull data. If you're getting into more experimentation or even real-time syncing between, what your actual deployed physical device is, car, factory component, whatever, and you need to sync that up with the digital twin so it's got sensor data moving in real time. Like, that's another whole order of challenge there. The thing that we're very focused on, which I think applies most to the digital twins, is this idea of data liquidity. So I think a lot of the focus of the technology industry for the last 20 years or so has been, got to get all the data, got to collect all the data, got to store all the data, right? And then that we've gotten great results from that, and a lot of analytical data, is very useful in that way. But the problem that a lot of organizations have now is they know they have the data, but trying to get the data to where it needs to be used in real time is very challenging. So I know it's out there somewhere. How do I get it to where it needs to go? And that's a big challenge in the digital twin space, where you want to, like, a lot of as you go higher up the maturity there, it's all about that real-time bi-directional connectivity between the digital twin and the actual physical entity. So that really is a digital liquidity challenge. And again, this comes down to being able to have a high signal to noise ratio, making sure that you're filtering out the unneeded information, both from providing the level of precision that's needed, as well as just the efficiency of moving smaller amounts of data. So anywhere where you're like, synthesizing multiple sources of data, filtering out data, and then moving it in volume in real time, like that's a role that we play. But I think it's, as an organizational capability, companies should be looking at data liquidity as much as they're looking at just storage of data.
Yeah, I understand. That's fascinating. Robots. Let's talk about robots on a factory floor. Where might Boomi have a story around robots? Because I'm thinking, those are computers on wheels with visual. They're in unstructured environments. They're looking everywhere. They're supposed to have a lot of knowledge, a lot of computational capability. Algorithms need to be grabbing data from digital twins, all of that in a moving humanoid body.
We bought a robot. I have to tell you, we have a robot named B1B that shows up at our events and does fun little things. And let me tell you, I've behind the curtain on that. It's a really interesting thing to watch. But generally, I think that if we think about smartphones, right? We say, oh, here's my smartphone, right? It's really smart until you take the network away.
Yes.
Right? And so the idea that that we would create a robot that would have all of the smarts on board that it needs that's not the way it rolls, right? Like we're if you think about people, we're all connected too, right? We have our sources of information. Not everything is in our brains. So I think any sort of robotic entity, we have to think about it as a physical proxy that has lots of connectivity to get all the information it needs. It's not going to be practical to store everything it needs. So again, it is another connected component. And I think the more software defined, the robots will be software defined and are software defined the way smartphones are and all the other physical entities we have out there. So really it's a matter of, again, giving it access to the capabilities and data sources that it needs. And this is a combination of our platform could definitely help there, but so could all those good practices around driving optionality in your environment and making sure that you've got that data liquidity to surface the data that you need in real time as quickly as possible.
So let's put it all together. There's AI, there's robots, there's robotic process automation, there's sensors, there's just regular automation that you would see out there on the assembly line floors. All of that is data moving everywhere. And in an ecosystem, some of that has to be chopped up and shared with different partners all along the way. It's time sensitive. Talk to us about that and where it's going. Where might that continue to go over the next 10 years?
Yeah, I think I'll put it this way. Like there's that William Gibson quote about the future's here. It's just not evenly distributed.
Right.
And that's the world we live in. So you could probably go find somewhere like the ideal smart factory environment, and it may be functioning perfectly well. But I don't know if that means every single company needs that right now. Like I think the path to success is sort of twofold. And this is very much the recipe we have in our book around how do you actually navigate this digital space. One is be experimental. Go out and find these things and play around with them. Try the technologies. That is part of the recipe that we've seen for successful innovation. Mm-hmm. Doing that as cheaply as possible is actually the right way to do it, right? So doing writing a big blank check for some big new piece of technology and jumping on you're jumping into the void a little bit there. But so playing around with the technology is important. But having that big time business outcome focus is so important here, right? As opposed to, so companies shouldn't be thinking about how do I become a modern smart factory. They should actually be thinking about, like, what are the things I can't do today that I might be able to do tomorrow based on this new piece of technology? And that should be the mindset in the experimentations as well. So keeping that, and then building things in a way that drives that optionality. So making sure that as you build solutions, like you have connecting points within the infrastructure. I mean, APIs are one, anything where you sort of provide an interface that can be used in different contexts. And then the third thing is like making sure you're always measuring back against your goals. So driving the feedback loops. I think if all the technologies out there, apply it in a way that is going to make sense for those business goals that you want to solve. And like I said before as well, sometimes you don't have to like shoot for the moon on what those business outcomes can be, because a lot of times by striving for a very practical business outcomes, if you do it in an optional way, you might stumble across one of those happy accidents that turns into the breakthrough that gets you to smart factory nirvana.
Thank you for sharing that. Last question. I've been pondering a lot the ability of automobiles and their, if you would, digital safety systems that could be put into a future car. Is it possible that a car could anticipate and understand that when it enters an intersection ahead of it, it could include all of the historic accident data from that intersection, any vehicle to pedestrian situations, any vehicle to vehicle situations that have happened, and prepare the vehicle before it even gets there to analyze and be hypersensitive to the possibility of those kinds of accidents. I'm thinking beyond the car itself, utilizing insurance databases, government databases, and physics databases, everything out there, and start making the car so incredibly smart. Are you seeing people do things like that?
So I got two paths on this answer.
Okay.
I would say, number one, this is a great example of the complexity involved, right? Because the scope, like the cardinality, the dimensional complexity of all that data is pretty massive. And to put it into a real-time context where like the safety information is making a real-time decision would require a projection onto a very thin, I think it would require a very projection onto a very thin, data point that would be needed by the car. So it's probably like theoretically possible, but the implementation would be really hard. But the other side of the answer to that is like, what is the error rate on that? And then what's the collateral damage that something like that could cause? And I was actually thinking about this the other day, how it'd be funny to take, I'm dating myself here, but when I think back to like the great car chase movies in the 70s and 80s, and Blues Brothers and Bullet and French Connection, all these car chases where like these cars are
Burt Reynolds
flying through intersections. Yeah, Smokey and the Bandit, like flying through intersections and like going on two wheels and all this stuff. If you were to do a scene like that today with all the digital safety features in a car, and how the bad guy is going to come up and try and ram your bumper, but then the safety engages and it pulls back on it would be just a ridiculous, more like something from a Naked Gun movie if you were to put that in. Yeah. So I think there's the could we do that, but then there's also what problems might that cause? So this is just, again, we're always dancing with complexity.
Oh yeah, I can imagine your car going, whoa, wait, whoa.
Exactly. It would be a ridiculous car chase. It'd be two cars trying to battle each other, and there'd be like a 6-foot buffer of safety space. Anyway.
This is a fascinating discussion. It's a fascinating topic. Boomi's booming out there right now. So I appreciate it. The name of your book again, and where can they get that?
Unbundling the Enterprise, and it's available on Amazon and lots of other places.
And if I go back up to my notes here, your podcast can be found where, and what's it called?
The API Experience, and it's on Apple Podcasts, Spotify, SoundCloud. We got you covered.
I love it. Matt, thank you so much for sharing with all of us today.
Thanks, Kevin. This is great.